All right, so when you are going to graph this first line, or any line, let's say, there are two types of lines that we learned how to graph. There's ones in what's called slope-intercept form and ones that's in what's called standard form. Would you consider that first problem on your paper slope-intercept or standard form? Slope-intercept. Slope-intercept. Standard form is going to be when x and y are on the same side of the equation, and that's not the case here. There are two different ways that you can go about plotting this line. The first way is you could use your calculator. So if the equation is negative 3x plus 5, I could go to the y equals screen and type in negative 3x plus 5. And then what I could do from there is go to the table and just pick any 2 points from the table that are plottable on the graph. What I mean by plottable is like, obviously I can't plot negative 22. There's not enough graph for that. So you want to pick one of the ones in here, 2 of the ones in here to plot the line. So one way to do it is to use your graphing calculator. Another way to do it is to use the slope and the y-intercept. So the first thing you'll plot is the y-intercept. The y-intercept of this equation is the one that's not with the x. So the y-intercept is 5. So on the y-axis, I'm making a point at 5. And then the slope is negative 3. But I need a rise over a run. So I'm going to put a denominator. And then if I don't have a denominator, I can put a 1. The bottom number will always go right. You never want to plot left. Just like you read a book from left to right, you plot a graph from left to right. The top number is either going to go up or down depending on the number. So because this one's negative, we're going to go down. So from that point at 5, I'm going to go down 3 and then right 1. I can continue that pattern, but I don't have to. Since it only takes 2 points to make a line, I really only need to do 2 of these. I like to fill the whole graph so that when I do my ruler, I can really make sure it's going through the right points. Okay, so before I grab the ruler app and connect these, I then have to consider if I'm connecting them with what's called a solid line or a dotted line. And that's going to come from this inequality symbol. Because it doesn't have a line underneath, I'm going to connect it with a dotted line. Andrew asked, can I just write dotted? That's totally fine, right? I just want to know that you know it's supposed to be dotted and not solid. So if you made a solid line, you can just add a note like this is supposed to be a dotted line. All right, so when I grab the ruler, I'm going to choose the dotted line. If you did a solid line, you're just going to make a note like I meant for this to be dotted. All right. Now what this does is it splits the graph into 2 regions. I need to figure out which of those 2 regions gets colored in because an inequality gets shaded. Okay, so to check which one gets colored in, we're going to test the point 0, 0. So I'm going to plug 0 in the y spot and the x spot of this equation. So here there's going to be a 0, and here there's going to be a 0. So I end up with 0 is greater than 0 plus 5. 0 is greater than 5. That's not true, right? 0 is not greater than 5. So I'm going to find that point 0, 0, and I'm going to write false. And if this side of the line's false, then this side of the line is true. Right? One side's true, one side's false. You want to shade the true. So when you color this graph in, you want to make sure you shade the side that's got the T on it. So all of this would be a solution. Anybody have questions on that one? Most of the time, the mistake kids make on this one is plotting the line itself, not necessarily the shading. So if you're struggling with plotting a slope-intercept form line, just use your graphing calculator and pick points from there. All right, now this next one is a system, so we're going to graph 2 lines, and the first line is in standard form. X and Y are on the same side of the equation. So if I'm looking at this, I'm just going to change it to an equal to sign for right now. The first thing I do is find the x-intercept, and we talked about this yesterday. I'm going to find the x-intercept by pretending like the minus 6y is not there. And then I can divide out that 2. So on the x-axis, I'm going to make a point at 6. And then I'm going to find the y-intercept by pretending like the 2x isn't there and dividing by -6. So the y-intercept is -2. And I'm going to do another dotted line here because this inequality sign is not inclusive, meaning there's not an equal to line with it. So I'm going to connect these 2 points as best I can. That was not good. So also maybe that bottom point. All right, so that's that line. Now, I'm not going to shade quite yet. Some of you might test 0, 0 now. That's up to you. I'm going to plot the second line next. The second line is a special line because there's only an x, there's not a y. When you have a special line where it's just x or just y, you're looking at your horizontal and your vertical line. When I see x, I think exclamation point. An exclamation point goes up and down. So this graph is going to have a point at -4, and it's going to go up and down. So I can just pick any points above it or any points below it to get my line. So this is a vertical line. And it's another dotted one, since we don't have a line with that inequality sign. So there we go. Now from here, what I notice is that I've got 4 regions of the graph. I'm going to number them. It doesn't matter how you number them, or even if you do number them. You just need to recognize that there are 4 areas of this graph, and only one of those 4 areas is going to get the colored in part, okay? So I have to figure out which one that is, and that's going to come from testing 0, 0. So I'm going to first test 0, 0 on 2x minus 6y is greater than 12. So 2 times 0 minus 6 times 0 is greater than 12. 0 is greater than 12. That's false. So it's helpful sometimes to take your ruler and put it on that line so you're only focused in on that line. So this is the blue line. And here's the point 0, 0. And so that point is above the blue line and it's false. So the 2 areas above the blue line, which are 2 and 3, are both false, which would make the 2 areas below the blue line, 1 and 4, true. So this blue line is breaking the graph into 2 regions, the true and the false. The 0, 0 is the false, so everything above is false, everything below is true. Now I want to test 0, 0 again, but I want to test it on x is greater than -4. So 0 is greater than -4 is actually true. So I'm looking at this line. This point is true. So this area is true as well, which means this is false and this is false. Okay? So I am looking to shade the region that's got the double true, which looks like it's region 4. Anybody have questions on that one? Anytime you have inequality symbols on a graph, you have to shade too, right? Like it's not just like graphing the lines, you've got to shade them. Let's see. Use the profit equations and corner points to find the maximum. So I'm going to take this profit equation and I'm going to plug these in. So 6 times x, well x is 2, plus 2 times y, well y is 5. So I've got 12 plus 10. So the profit for this first point is 22. I'm going to do that for all of these. So I'm going to find the profit for the second point. 6 times 5 plus 2 times 5. So I've got 30 plus 10. So the profit for this one is 40. And then 6 times 3 plus 2 times 8. 18 plus 16, 34. So it says the maximum profit is. So now that I have worked all of those out, I am looking for what number is the biggest. And I'm going to say that the biggest profit is $40, since usually profit is money. And that happens at the coordinate point 5, 5. If you didn't put it in that exact format, it's totally fine. The test is going to kind of put the blanks for you to fill in. So you'll know what to put where. When you see it, it'll be more laid out a little more clearly than that way. The last one says, set up the constraints from the given application problem. So there are 4 blanks. I know that the first 2 are always going to be this, so I'm just going to get those 2 out of the way. Right, we always have our zeros. In this problem, we're talking about cookies and cupcakes, and we can't have negative cookies or cupcakes. So that's that part. It says, a baker is attending a food festival to sell the treats she bakes, cookies and cupcakes. She has rented a booth that can hold no more than 100 items. It cost her $2 to bake a batch of cookies and $5 to bake a batch of cupcakes. She has at most $400 for her budget. Let X be the number of cookie batches and Y be the number of cupcake batches. So what I'll do is I'll read through this problem and I'll pick the 2 biggest numbers. 100, and I'll label that as items. And 400, and I'll label that as money. So then from there, since I only have 2 blanks, if there's any other numbers in the problem, they're going to have to go in those 2 blanks. So the other numbers in the problem are 2 and 5. And because 2 and 5 both have dollar symbols with them, I'm going to put them with the orange equation. When I'm not left with any numbers, I either am going to put an X only, a Y only, or an X plus Y. And that depends on what the category is. If this was 100 cookies, I'd put X. If it was 100 cupcakes, I'd put Y. But it's just items, which is more of a general category. So I'll put X plus Y. And then finally, I need to know what symbol goes with that. For the blue, it's no more than. If it's not more than, then it's less than or equal to. And the 400 is a budget. And remember, if you go to the store with money in your pocket, you can spend all that money or less than. You can't spend more than you have. So this is another less than or equal to. Hopefully that served as a pretty good summary of what we did in this unit. Today we're going to practice those concepts. So today the goal would be to, oh, did anybody do this? If you did the substitution problem here, this. So I looked at the coefficients and saw the x's alone. So I solved for x by subtracting the 9y to the other side. And then I plugged the x into the equation. Worked my way through. So today our focus is going to be on graphing and shading linear inequalities in both slope, intercept, and standard form, writing objective functions and constraints from those application problems, those long problems, and then being able to find the corner points and test them from those long problems. So all of the linear programming stuff. So we're going to do a similar format to yesterday, which is going to be self-paced. So if you open your workbook to page 15, there's going to be a template for you to complete 5 problems. Those 5 problems are posted around the room. You got to make sure you're doing number 1 in the number 1 spot, because numbers 1, 2, and 3 involve graphing, and those are the ones that have graphs, right? So you got to make sure you're doing them in the right spot. You're going to complete the problems at each station, and you're going to check your answers by lifting it up and checking below, okay? Self-paced. When you're finished, you're going to go back to your desk. If you didn't do the geometry software from yesterday, I highly recommend that's where you start. since we're not doing geometry review in class, you definitely want to make sure at some point between now and tomorrow you do some geometry review on your own. So that would be my first option. If you did that already, the test review guide 7 through 10 and numbers 1 through 14 is all of the stuff that we reviewed yesterday and today. So the non-geometry stuff. Questions before we get started? Instead of giving you a specific station, I'm just going to split you. So from you two are going to go this way. So you're going to be blue on this side, and then from you guys over, you're going to be yellow. Okay, so you just have to find a blue station or a yellow station. I don't care which one, but that's just to keep us separated so the class is spread out. You're moving at your own pace. Let me know if you have questions. Otherwise, move at your own pace. Check your answers. When you feel confident, work on some geometry.